Transportation of oocyte or ova in the oviduct. So in this topic, what are the factors it facilitates the transportation of ova after ovulation in the oviduct. So the factors, the peristalsis and antiperistalsis contractility of oviduct that facilitate ova transport, ciliary activity and also the secretory activity that also facilitate the transportation of ovum in the oviduct. The contractility, ciliary movement, and the secretory activities are controlled by physiological, pharmacological, and neurological mechanism. So, in this topic, we will see ovum pickup, type of contractility of oviduct, and transportation of ova in the oviduct, and locking and unlocking of ova in the oviduct. So, let us see the ovum pickup. The muscular activity of the infundibulum, especially the end part of infundibulum, increases at the time of ovulation. So the end part of infundibulum, it is a funnel shape and it has fambry, and those muscular activity of the infundibulum, it increases at the time of ovulation. Even the fambry, which is present in the infundibulum at funnel shape structure, the activity of the fambry also increases at the time of ovulation, and it sweeps over the ovary to pick up the ovum as soon as it ovulates. So the activity of the fambry and the movement of the infundibulum also important to receive the ova from at ovulation. The fambry and the ovary come close to each other at the time of ovulation by the activity of ligaments and the muscles around them, around this structure, and they become close to each other, and fambry it move over the surface of the ovary, so that as soon as the ova release they receive, and it facilitate the movement toward the ampulla or in the oviduct. Fambry are engorged with blood at the time of ovulation. So that's how the ovum is picked up just at the time of ovulation. So what are the type of contractility in the oviduct? The contractility of the oviduct is controlled by endocrine, pharmacological, and neural mechanism. Peristalsis contraction from ampulla to ampullary isthmus junction, and peristalsis contraction from uterotubal junction to ampullary isthmus junction. So this we have the structure of oviduct, and it has several segments. This part is called infundibulum. Then we have ampulla, then isthmus. So the peristalsis movement, it is from this side toward the ampulla or isthmus ampullary junction from this side. And another peristalsis movement, it starts from uterotubal junction from this part toward the uh, isthmus ampullary junction. So this peristalsis movement, sometimes we call it antiperistalsis movement and peristalsis movement. So this peristalsis movement, which is from infundibulum toward the ampullary isthmus junction, it facilitates the transportation of the oocyte. And another peristalsis from uterotubal to the isthmus ampullary junction, it might facilitate the sperm transportation, but it also affects some amount of it also reduce the oocyte transportation, because it is opposite to this peristalsis movement. So these are the movement we can see in the oviduct, and also there are contraction of circular musculature in the isthmus. This circular musculature in the isthmus. So every contractility play very significant role for the movement of the oocyte as well as also the movement of the embryo after fertilization. Transportation. So definitely the contractility of the oocyte it facilitates transportation. So what are the other factors that transport helps in facilitating the oocyte transport? The beat of kinocilia and the secretion of non-ciliated cells facilitate the ovum transport in the oviduct. The secretory activity is primarily controlled by estrogen and progesterone ratio, ovarian hormone. So these are the lining of the oviductal cell, lining cell of the oviduct, and some of the cells they have the cilia, and some cells they don't have the cilia. So those non-ciliated cells they secrete fluid, and the ciliated cell they facilitate from by the beating of the cilia they facilitate the movement of the oocyte in the oviduct. So this is the oviduct which have different segments. These lining cells are ciliated cell as well as non-ciliated cell. So this cilia they facilitate the oocyte transportation after receiving, then it facilitated toward the ampullar isthmus junction. This cilia also play a very significant role, and non-ciliated cell they facilitate the secretory fluid that also facilitates. Fertilization takes place at isthmus ampullary junction, or sometimes we call it in ampulla. That is, so sperms are transported from uterotubular junction and oocytes from infundibulum toward the isthmus ampullary junction. So what do you mean by locking and unlocking of ovum? So the mechanism that slows the movement of ova in the oviduct, especially in the isthmus, this portion. So these mechanisms are tubal peristalsis, ciliary activity, fluid current, and counter currents within the lumen, sustained contraction of circular muscle in the isthmus, the slow transport of ovum in the oviduct, especially in isthmus, is referred to as locking and unlocking of ova. So, because fertilization takes place at ampulla or isthmus ampullary junctions, so the peristalsis movement from uterotubal toward the isthmus, it is from this side toward the isthmus ampullary junction. Peristalsis movement from tubular uterotubal junction toward the isthmus ampullary junction. It prevents or slows down the oocyte movement, and the circular activity of the isthmus is also facilitate the slowing down of the oocyte, so that it will fertilization take and the movement of the oocyte is slows down in the after fertilization when it form the embryo. So the mechanism it involved the tubular peristalsis movement from this side to this side. Sometimes we call it antiperistalsis, and the fluid secretory by the these are also affects slows down the oocyte to move in the oviduct. But however, from infundibulum toward the ampulla, it is quite faster the movement. But from isthmus ampullary junction, the tubular peristalsis movement as well as fluid secretion in the oviduct and countermechanism that slows down the oocyte movement, and that is referred to as locking and unlocking uh, of ova.